This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. The field decision at the center of this lesson is simple to state and expensive to misunderstand. During residential type framing in California, 6 feet is now the basic trigger for fall protection. The old habit of thinking in terms of a 15-foot framing threshold is outdated. More important, the rule does not automatically mean every carpenter must solve the problem with a harness. It means the employer must provide a conventional fall protection system that actually fits the work, the structure, and the available fall clearance. That distinction matters because a protection method can exist on paper and still fail in the real geometry of the job. A lanyard needs room to stop a fall. A scaffold needs the right platform position and gap. A guardrail has to protect the opening without blocking the work. The supervision question is not, did somebody bring safety gear? The question is, what system protects this task at this height before the worker steps into exposure? The 6-foot framing trigger took effect on July 1st, 2025. California had previously used a 15-foot threshold for the residential type framing activities covered by this rule. Industry groups sought a delay, but the Standards Board denied that delay. For current field supervision, the date to remember is July 1st, 2025, and the number to remember is 6 feet. The trigger applies when an employee walks or works on top plates, floor joists, rafters, trusses, beams, starter boards, fascia boards, or similar structural members 6 feet or more above the surrounding grade or the floor level below. I want to stress the measurement point. I am looking from the walking or working surface down to the level below. I am not measuring from the worker's head, from a nearby ladder step, or from the top of a parapet. I put the first reference chart on screen because the scope is broader than the word residential suggests. Residential type framing is a construction method category, not merely an occupancy label. A commercial building framed with traditional wood materials and methods can fall within this rule. Limited structural steel, such as a steel beam supporting wood framing, does not automatically take the project outside the residential type definition. That means a superintendent cannot look at a light commercial address and dismiss the framing rule as house only. I would ask what materials and framing methods are being used, what surface the employee will stand on, and how far that surface is above the level below. Those facts control the first safety decision. At 6 feet or more, conventional fall protection is the default. The listed methods include scaffolding, guardrails, safety nets, and personal fall protection systems. The employer does not get to treat those systems as optional merely because they slow production, require more staging, or are unpopular with the crew. This is where the legal hierarchy changed the job site conversation. California now presumes that conventional fall protection is feasible and does not create a greater hazard. A fall protection plan is not a casual substitute that a foreman can choose because a safety monitor feels easier. Outside the narrow interior framing exception I will explain shortly, the employer must demonstrate that conventional methods are infeasible or would create a greater hazard before relying on the plan. The useful memory connection is default versus exception. Scaffolds, guardrails, nets, and personal systems are the default. A fall protection plan is the exception. Cost, convenience, and habit do not by themselves establish infeasibility. Suppose a crew plans to set trusses from 10-foot top plates. The supervisor says, I will place one employee on the slab as a monitor, and the carpenters can walk the plates. That is not enough. At that height, the employer first has to select conventional protection that works for the task, or meet the documented conditions for a lawful plan. A person watching from below does not erase the exposure. A lawful fall protection plan separates two roles that are often mixed together in casual conversation. A qualified person prepares the site-specific plan. A competent person implements and supervises it in the field. The comparison chart shows the clean division. The qualified person brings the recognized education, professional standing, or extensive knowledge, training, and experience needed to solve the fall protection problem and prepare the plan for that site. The competent person is capable of identifying existing and predictable hazards and has the employer's authority to take prompt corrective action. I remember the difference this way. Qualified designs the answer. Competent controls the day. That memory aid is not a substitute for the definitions, but it keeps the roles from trading places in your head. The plan must be specific to the site and kept at the job. A generic binder copied from another project does not satisfy the requirement for a site-specific plan. The plan is an administrative control built around the actual work, actual access, and actual hazards. If the framing sequence changes, the field supervisor cannot pretend the original conditions still exist. The narrow interior framing exception is the part that deserves slow, exact attention. It applies to interior framing work between 6 and 15 feet above the surrounding grade or floor level. In that window, an employer may use a fall protection plan with a safety monitor and controlled access zone without first proving conventional protection infeasible, but only when every listed condition is met. I use 3 checks. First, the structural members must be securely braced, or floor joists must be laid flat on their sides on the top plate during installation. Second, the member spacing must not exceed 24 inches on center, unless plywood sheathing completely covers the spaces. Third, workers must remain more than 6 feet from every unprotected side or edge. Braced or flat, 24 inches or covered, more than 6 feet from the edge. All 3 conditions travel together. Missing one condition means the exception is not available. Consider a hypothetical basement frame with a 9-foot drop to the slab. The crew is laying floor joists 16 inches on center in the middle of the footprint. The joists are braced or laid flat during the layout, and a safety monitor keeps workers more than 6 feet from the unprotected perimeter. Those facts fit the stated conditions for the interior exception. Change only one fact. Suppose the same worker moves within 4 feet of the unprotected exterior edge. The interior location does not save the operation. The worker has left the protected conditions of the exception because the required edge separation has disappeared. This is the central cause and effect. The exception works only in a controlled interior zone where stable members, limited openings, and distance from the leading edge reduce the exposure described by the rule. Once spacing opens up, members are unstable, or the worker approaches the edge. The factual basis for that exception is gone. Fall protection does not replace structural stability. The rule prohibits employees from walking on or working from top plates, joists, rafters, trusses, or beams until the members are securely braced and supported. I treat that as sequence, not paperwork. Stabilize the member before asking it to become a work platform. When a crew manually raises a framed wall 15 feet or more in height, temporary restraints are required to prevent sliding or uplift. The documented examples include cleats on the floor system or straps on the wall bottom plate. Anchor bolts alone cannot be used as the blocking or bracing for that operation. Imagine a contractor who says the sill anchors are already installed, so the wall cannot go anywhere during the raise. That statement confuses final anchorage with temporary control during movement. The immediate problem is horizontal sliding or uplift while the wall is being rotated. The rule calls for temporary restraint that addresses that motion. Truss setting adds another temporary support detail. When a truss support plate is used, the specified assembly uses a nominal 2x6 plank laid flat, secured lengthwise to a nominal 2x6 plank on edge, with nominal 2x4 legs. The legs are spaced no more than 6 feet on center and the support receives adequate diagonal bracing. I would verify that temporary support before production pressure turns it into an improvised platform. Scaffolding can solve the exposure without requiring a worker to depend on fall arrest clearance, but only when the scaffold is positioned correctly. For a scaffold used as an edge protection platform beside the top plate, the platform must be fully planked. It must sit no more than 2 feet vertically below the top plate. The horizontal gap from the inboard edge of the platform to the framed wall must not exceed 16 inches. The chart reduces that check to 3 lines: fully planked, 2 feet or less below, and 16 inches or less away. Those dimensions are not decoration. A platform placed too low leaves a worker exposed above the protection. A platform set too far from the wall creates a fall opening between the scaffold and the structure. Suppose a scaffold deck is beautifully built but sits 3 feet below the top plate. The quality of the planking does not cure the vertical mismatch. Suppose the deck is at the right height but leaves a 20-inch gap at the wall. The correct elevation does not cure the opening. The geometry has to work as a complete system. Wall openings require the same discipline. Future window locations generally need guardrail protection. The guardrail may be removed immediately before installing the window only when removal is necessary to fit and install the window components. I would not treat that limited removal as permission to strip opening protection early and leave it off while other work continues. Framing often crosses into roofing at starter boards, fascia, roof sheathing, and work near the eave. For roof slopes from flat through 7 units of rise and 12 units of run, the 6-foot fall distance trigger applies. When the slope is greater than 7 units of rise and 12 units of run, conventional protection is required regardless of height. That steep slope distinction prevents a common shortcut in reasoning. A worker can be less than 6 feet above the level below and still require a conventional protection when the roof pitch exceeds that threshold. The slope changes the rule application. The parapet is another easy place to make the wrong measurement. For the roofing trigger, the fall distance is measured vertically from the walking or working surface to the ground or level below. The height of a parapet is excluded. A roof surface 10 feet above the level below is evaluated as a 10-foot fall distance even if a 3-foot parapet stands at the edge. I would still evaluate whether the parapet or another system functions as compliant protection under the applicable requirements, but I would not subtract parapet height from the fall distance calculation. Measurement and protection are separate questions. Personal fall arrest systems deserve a clearance check, not a reflex. California limits free fall to a maximum of 6 feet and maximum deceleration distance to 3.5 feet. Free fall is the travel before the system begins applying stopping force. Deceleration distance is the additional travel while the energy-absorbing part slows the worker. The reference chart shows why those two numbers cannot be blended into one vague idea. At their maximums, 6 feet plus 3.5 feet equals 9.5 feet, before adding other clearance factors such as harness stretch and a safety margin. That simplified sum is not a complete design calculation. It is a warning against assuming that a 6-foot trigger can always be solved with a 6-foot lanyard. Consider a worker standing on a 9-foot top plate with an anchor arrangement that permits the full 6-foot free fall. The maximum deceleration distance alone can carry the total travel beyond the level below before other factors are counted. The correct supervision response is not to guess that the equipment will catch the worker in time. The response is to select and verify a system whose anchorage, connection, and clearance fit the actual geometry. This is why the central lesson is planning, not just personal protective equipment. A guardrail or scaffold may control the exposure without requiring a rest distance. A personal system may work when the anchor and equipment are designed for the location. The rule identifies acceptable categories, but the contractor still has to choose a workable method. I would build this rule into estimating in sequence before framing starts. I would identify every walking and working surface expected to reach 6 feet. Decide where guardrails or scaffold platforms can be installed. Determine which tasks may use a properly designed personal system, and isolate any interior operation that might qualify for the narrow exception. I would also assign the 2 plan roles correctly. If a fall protection plan is necessary, the qualified person prepares the site, specific plan, and the competent person supervises implementation and corrects hazards in the field. I would keep the plan at the job and revisit it when conditions change. A useful pre-task conversation can be brief. What is the level below? What is the worker standing on? Is the height 6 feet or more? Is the task framing or roofing? What conventional system protects the exposure? If someone proposes a plan instead, what exact exception or documented infeasibility supports it? If the answer depends on the interior exception, are the members stable? Are spaces 24 inches or less or covered? And are workers more than 6 feet from the edge? That sequence respects the contractor who already knows how to frame. The new burden is remembering that an old production method may no longer match the current legal trigger. Experience still matters, but the controlling number changed. I want you to leave with 4 clean distinctions. 6 feet is the framing trigger, not 15. Residential type describes the framing method and can include wood frame commercial work. Conventional protection is the default, while a fall protection plan is a limited exception. A qualified person writes the plan, and a competent person runs it in the field. For the interior exception, hold onto the 3-part memory line: braced or flat, 24 inches or covered, more than 6 feet from the edge. For scaffold edge protection, remember fully planked, no more than 2 feet below the top plate, and no more than 16 inches from the wall. For fall arrest, keep free fall separate from deceleration distance, because clearance is the sum of more than one movement. Official preparation resources identify framing and personnel safety as key areas for a general building candidate. I am not predicting a particular exam question. I am giving you the current source-backed field distinctions that let you reason through a safety problem instead of relying on an outdated 15-foot habit. There is an audio practice quiz for this specific episode and this exact framing fall protection material. It is audio-based, with each question read aloud and each answer selected by tapping, because I know you may be studying while driving, working, or moving between jobs. Go to the description below this video. You will see a link that says, "Pass the CSLB." Tap it. It will take you straight there. Comment below with any questions about the 6-foot trigger, the interior exception, fall protection plans, scaffolds, or clearance. Subscribe so I can help you stay on track through every episode until you get your license. I am rooting for you, and I want this material to feel clear when you have to make the call in the field.